Welcome to this FPOD video tutorial. This one is about validating FPOD detections, and the aim here is to establish that the error rate in your file is low enough to be safely ignored so you don't have to do any editing. Um, there's more about this in a useful document that's on the website. Um, and one of the things it says is that you can do better than the FPOD software because you can take a wider view of the data. You might ask why. If I can tell you how to do it, I didn't tell the software how to do it, and it's a good question. And the answer is it would be possible, and it's quite a large piece of work, and it needs an awful lot of testing. And basically, I ran out of time, and also I could never be sure of finding things that weren't in the data. New things might come along. So you guys have to get familiar with looking at this data. All right. And here we will start here. So here is a file, just to show from start. It's got, what has it got? Let's just see what it says. 7 days of data. We're just going to look initially at porpoises, that's MBHF, none of the other species classes, only the good ones. And we'll go to say 10 milliseconds to show from start. We're seeking in file 3, that's that one. So these two are FP1s, those two are FP2s in this case. And we'll do show next screen. Okay, so I'm just going to hit F5 to increase that and zoom in a bit. So these are nice porpoise click trains. They've got this nice rounded profile, which you don't get with sonars. They're not terribly loud. You can see a bit of multipath down here. So these are echoes of those clicks, and they generally occur with the louder clicks. And in the case of porpoises, they're at a similar frequency to the primary pathway. And we'll just zoom out again to get to, say, 100 milliseconds. And we'll look for similar click trains before and after. So for porpoises, we can look at the narrowband high frequency index. It's a sort of composite that tells us how much the click resembles a porpoise click. Is it the right frequency, the right sort of length, with the loudest cycle at a suitable position in the click? And as we look earlier in time, we see, yeah, so I'm moving earlier here. There's quite a lot of detections before this one. And as I go later, there's some there as well. So this is part of an encounter. So I'm feeling very confident about that. And what I'm going to need to do actually is look at a proper sample of these. So I go to filters and files, and down here it says find 100 sampling points, set validation sampling points, and that's going to want to know which file to look in to set these. So I'm going to say select this file for action. That's an FP3. Okay, so it's whizzed through, found 100 points, spaced at more or less evenly through the actual click trains that are going to count in your data. So that's the kind of correct way to sample it. Do Control and S, and that's the one we looked at already. Here's the next one, and again, we've got quite nice rounded click profiles. We've got a high NBHF index. I hardly need to look further. Actually, there wasn't much before this, and there was a little bit after it, but I'm happy with it because it's very typical. Um, and same thing again. Um, these are such high values, and kind of everything about it looks reasonable that I'm just going to accept that without looking for the rest of the encounter. That's good. Here you've got an animal clicking very slowly and then speeding up. So I'm going to increase the click rates up there to get the feel of that. Yeah, these are very slow. These are about as slow as porpoises go, but it is correct. At that point, the porpoise is looking about 250 meters ahead. Yeah, so there's some fast click trains up here. We could pull them down just out of interest. Um, okay, okay. So these are basically all good porpoise detections. Um, and if you feel you've gone too fast and you want to go back and check something, just do Control and Z. So there was a bit of an upsweep back here. See if it will take me. Oh, there it is. That one there. Yeah, so that's okay. It's all good. Okay, so let's switch to looking at other cetaceans, which will be dolphins. I did look through that for all 100 click uh, trains were correct, but I've got to set the validation sampling points again because they're um, in dolphin detections. Show from start, Control and S. Okay, so this is the first one. Um, we're not really so interested in narrowband high frequency index now because we can tell from the colors these frequencies are way off what porpoises use. So we'll look at clicks per second in this file and just refresh that. So the question here is, could this be a sonar? It hasn't got those nice rounded humps we had for the dolphin click trains. So we do need to look sort of earlier. Um, and what we're seeing is there are sort of distinct bursts here. There's no flat line running through there of very constant click rates. But it is all surprisingly low frequency. So it could be a dolphin that uses very low frequencies or is very distant. And so a lot of the higher frequencies are being filtered out. Let's see what happens if we graph it. Oh, data shown too short for DL graphing. So what were we showing? Kilohertz. Yeah, we could have done, say, narrowband high frequency index there, kilohertz in the dolphins, and clicks per second. Okay, graph. Okay, so that's the frequencies in the dolphin click trains. They're not, not impossibly low for dolphins. Um, click rates are okay. Narrowband high frequency index, they're all very low. Okay, I'm happy with that. So we'll do Control and S. And we've got another group here. Zoom in a bit. And you can see the multipath here. If we look at that as frequencies, you get these vertical lines because the multipath from a dolphin click train has a lot of different frequencies in it because the beam is so structured. You've got high frequencies in the middle and these lower frequencies off to the side. So here the dolphin's pointing right at the pod, but these pathways are coming out of the dolphin at wider angles and then getting bent in towards the pod. That's absolutely classic, kind of very convincing for a dolphin. Yeah, so this is all good stuff. We're hardly even needing to look at the clicks, the wider evidence of the encounter. Lots of structure here in the FP1 file due to the multipath propagation. If I zoom out a bit here and sort of scroll forwards and backwards, yeah, there's a lot of other dolphin stuff around. So again, actually, all 100 detections did turn out to be dolphins. So now we'll look at sonars. We will do the setting the 100 points. It's done that. Show from start. Control. Okay, so this is immediately looking very different. We'll put the click rate scale here because these are mostly going to be low click rates. So you've got a very flat click rate there. Same thing showing through there. It's so this is absolutely the hallmark of sonars. So if we look a bit, we'll can zoom out a bit more. So the boat comes into range, we get a lot more clicks appearing, we get that rather regular thing. And then when it gets close, we kind of lose that regularity because the multipath is so heavy there that the gaps between the clicks are filled up with it. You can see that there. And if I make that amplitude, or I'll make it a number of cycles, that'll be even more illuminating. Yeah, you can see these huge bursts with very long cycles. So very typical of a sonar. So the useful thing there is that recognizing that flat line that goes through in the FP1 and is a kind of giveaway for boat sonars. You can sort of see it every. We don't seem to be moving forwards there. Maybe I've caused it to abandon its sequence. Just do that again. Okay, that's the first one. Okay, it's not moving forwards. I'm not exactly sure why that is. I will check that. I'll treat that as a bug and check it out. So we've got the sort of principle there, the features of each one. What we haven't seen is one that wasn't from any of those classes, but was unclassed. And actually, there aren't any in this file. So I have to, or there were some, but they were either one of the three classes we've seen above. They weren't just noise. So I will close all files. I'll open a file set. I'm looking for one called Ophelia, the name of a big storm we had here. Oops. Ophelia, there it is. And I've got to look for something that wasn't classified as good quality. It was basically rubbish. And here I can do go to saved time point. And it's taken me some way into the file, actually most of the way through, um, to this point in time here where there's a sort of burst of noise building up over part of a minute. Um, and I'm going to look at that as amplitude. And clicks per second here's gone up off the top of the scale. So I hit F6 to bring this down. And this actually is the commonest way you get errors. So there's a huge noise burst here caused by massive waves coming in. That sediment transport noise down here, this is sort of breaking waves at the surface. It's maxed out this minute quite early on. That's always a warning sign that these may be wrong. And then if we zoom in on the click rate, it's very uneven. Um, the uh, the amplitude profile is very irregular, and if we um, if we move back and forwards, it doesn't really form part of an encounter. You know, there are no other click trains up here, and down here there are other things which didn't get taken to be forming click trains, but they're showing us this sediment transport noise. So as the wave goes overhead, the seabed is moving and creating a lot of noise. Okay, I've thrown a lot of stuff at you there. I hope it made sense. Thanks for surviving this one, and please send any questions. And I promise to fix the Control S bug. Okay, bye.